please watch that video on YouTube channel, and it is the practical part of granulation. First of all, to make a tablet we look for the raw material. If it is fine, that fine powder, it is uncompressible, so we have to make it granules. Granules is compressible. So we have two methods of granulation: wet granulation technique as in our lab, and dry granulation technique. What is the difference between them? It's the presence of water in the binding agent. If I add water to the binding agent and use it to make a dough or a mass, then make granules out of that mass and dry it, that is wet granulation. So the raw material must be stable in moisture, no hydrolysis, and stable in heat, no degradation by heat. So I can use wet granulation technique, and there will be left of moisture content that will enhance compressibility. Why? If the raw materials were fine and prone to degradation by heat and water hydrolysis, so the best method for granulation is dry granulation. We have really two methods for dry granulation. We can use large instrument, we call it roller compactor, where two rolls are used and we add the powder, fine powder, between them. They will compress into a ribbon or a sheet, large sheet. This ribbon or a sheet is cleaved, يقسم, and we form granules. These are dry granules. Roller compactor, or by slugging, large compression machine that compress the powder into sheet, or roller compactor compress the powder into a ribbon, that will followed by fragmentation into dry granules that will used in tablet manufacturing. What is the really importance of a granulation? First of all, granulation is the process in which we adhere small particles to form large particles. We call it granules, and as I said, it is important in tablet manufacturing. The typical size will be from 0.2 to 0.5 millimeter or 200 to 500 nanometer. So why we are doing a granulation? First of all, to prevent segregation. If you have powder mixture with different particle size, different densities, it's prone to mixing and vibration that make these powder will segregate according to their particle size or density. The smaller, the denser particle will be at the bottom, and the larger, less denser will be at the top. If we add that mixture to the tablet die, that will make the tablet contain less content uniformity. So if we mix the large and small particles in the same proportion, we want the same concentration of the drug, and form one large particle granule, during manufacturing, vibration and agitation, no segregation according to the size, and the filling technique is the same, so the amount of the drug will be nearly the same, so it will enhance content uniformity. The second reason for granulation is to increase the flow probability of granules. As we said, the granules are larger and resemble a sphere. The contact point between the sphere and sphere is less, so less cohesive and adhesive properties between these large granules that will increase the flow property. If we have small particle size, the surface area will be large, contact points will be higher, cohesive and adhesive forces that opposite of a flow will be higher, and it will be cohesive, non-flowable powder. So by enlarging the granules, that will make less contact point, resemble a sphere, so enhance the flowability. The higher flowability and constant flowability, the amount, the rate that tablet dye is filled is nearly the same, so it will enhance content uniformity. Also, the third reason for the granulation, the advantages, is to improve compaction characteristics, especially in wet granulation technique, in which we gather the fine powder and we add the binding liquid. It will be the binding powder plus water, okay, and we will form a mass or dough that will be friable mass or dough, and press it into sieves and make granules. These are wet granules, are put in oven. So dryness will make water inside these granules move from inside of that granules to the outer layer and make the binder powder as a layer around that granules. When we gather these granules, a new bond, stronger bond, will be formed between binder bond, between the binder bond available in the outer layer of granules, and that it make it more compacted. It is assist consolidation for weakly bonding materials. Other reasons: if we have fine powder of hazardous toxic materials and it will move during manufacturing, it will form a dust. That dust is very dangerous to the working people. They can inhale it. Also, a loss of active ingredient, contamination. So by transforming these particles in fine powders, hazardous drug, into granules, tendency of dusting will be less toxicity and less contamination and less losing the active ingredient. Also, if we have hygroscopic powders materials, if they were fine, the surface area will be high, the higher amount of water will be absorbed at their surface, they will form hard cake. So by transforming these hygroscopic fine powder into granules, that will reduce the surface area of these powders, these materials, and tendency of forming a layer of water is less, tendency of forming hard cake is less. This is important for preserving the dry powder, because we have to store it in a dry place. As we said, we have two methods of granulation: wet granulation technique, as we will do in our lab. Watch the video please. We will gather the fine powder, we will form binding liquid, I called glue. We will add binder as a powder in a water and form starch mucilage. We will add optimum amount of that liquid into the mass, into the powder, forming a mass or dough. friable، رح احكي شوي بالعربي، رح تكون العجنة او العجينة رح تكون هشة، يعني اذا جمعتها بايدي رح تنجمع، اذا ضربتها باصابعي رح ترجع تتفتفت، مرتبة مش مبلولة. Then we are going to press it into a sieve of desired size or mesh number. Then we are going to dry it. Then we mix it with other ingredient, and then using compression machine and make a tablet. While a dry granulation, as I said before, we don't use water or liquid. We add the amount in a dry powder form. Even if I use a binder, it is in powder form. Mix it using slugging, where compressing into sheet, or roller compactor, forming a ribbon that will be fragmented into granules. Then the rest of material are added and mixed, then compression again. So we call it dry granulation, we call it double compression, really, because it is compressed twice. The first compression for forming the slug or ribbon, the second compression for forming the tablet. Our formula is to prepare 50 tablets of paracetamol. These are the formula for 1 tablet in milligram and 50 tablets in a gram. So the active ingredient is paracetamol 500 milligram per 1 tablet, by multiplying it with 50 and dividing it with 1000 to form a gram. We have 25 grams of paracetamol. This is the active ingredient. The weight of the tablets is 600 milligram. So the amount of excipient added is very small compared to the tablet weight. So what we have really to add, we will add diluent, but really we will add lactose as a diluent, but in very small amount. 8 milligram per 1 tablet, multiply it by 50 and divide it by 1000, it will be for the whole 50 tablets 0.4 grams. I can really omit lactose as a diluent, because the purpose of diluent is to enlarge the bulkiness of the powder and the tablet. If I have active ingredient less than 50 milligram, I will add larger amount of diluent as lactose to increase the tablet weight, to make it bulky, to make it more noticeable, handleable, weighable. But because 500 milligram as a paracetamol in our tablet, it's weighable, handleable, noticeable, I need very minute amount of lactose. Diluent could be added for different purposes, not for increasing the weight or the bulkiness only, but it can enhance compressibility. I need to add a dry starch 5% out of the 600 milligram. If we multiply 5% with 600, it will be 30 milligram per 1 tablet. This is dry starch, we call it disintegrant. The purpose of that disintegrant is to disintegrate the whole tablet into granules and disintegrate the granules into fine powder. So we will add it in 2 positions. First of all, while we're forming the granules, we will divide 30 milligram by half. It will be 15 milligram per 1 tablet inside the granules, and 15 milligram outside the granules. The most important part, it is outside the granules of dry starch 5%, the disintegrant, because if we don't add dry starch or disintegrant outside the granules, the tablet will remain intact. So if we add half the amount of dry starch outside the granules, that will transform the tablet into granules, and if we add the rest of the dry starch inside the granules, that will transform or disintegrate the granules into fine powder, and dissolution and absorption will happen and bioavailability is achieved. So 30 milligram, this is for 1 tablet of dry starch, multiplied by 50 and divided by 1000, it will be 1.5 grams. So I will divide 1.5 gram into 2 halves. 0.75 inside the granules and 0.75 it will be left outside the granule. As I said, the most important part, it is outside the granule. If I don't add disintegrants inside the granules, I will transform the formula into controlled or sustained formula. This is an idea, but we will divide it into two halves. As I said, we will use wet granulation technique, so we will form 5% mucilage glue binding liquid by adding the powder into water and form mucilage. That is explained in the practical part. 5% means 5 grams of starch in 100 grams of water, 100 ml of water. So we are going to prepare 50 ml of water, so we are using 2.5 grams of starch. Because we are going to use heat in order to degrade starch, the polymer of glucose, partially into dextrin, that will make it more viscous and we can use it as a binding liquid. So we can divide the 50 ml into three parts. 40 ml boiling water and 5 ml in small beaker room temperature water and 5 ml in graduated cylinder for rinsing. Starting up with the small beaker containing 5 ml of the water, we add 2.5 gram of the starch and stir it. That will form suspension. Easily transformed to the 40 ml boiling water, no clumping, no aggregation, and we mix it. Because it is suspension, the 5 ml small beaker will remain small powder of the starch, so we use the rest of 5 ml in the graduated cylinder to rinse the small beaker and still add it into the large beaker. That will be 2.5 gram of starch in 50 ml of water. We add it in hot plate and mix it less than 1 minute. It will be boil, and the color of that white mixture is transferred to less whiter viscous. It is a translucent white mixture, viscous. We take it, we want to take optimum amount. As we experience that formula, we need only 8 ml, so we cannot use the boiled mucilage. We have to cool it first, then we take just 8 ml. So how we prepare our granules? Just weighing 25 grams of paracetamol, 0.4 grams of lactose and 0.75 of a dry starch, and preparing the 50 ml of starch mucilage and just taking 8 ml. We mix the three powders in mortar using a spatula, because these powders are very fine powder, using geometrical technique, starting with lactose and double it with dry starch and paracetamol gradually to make homogeneous mixture. Then we add the whole 8 ml of starch mucilage and make a dough. العجنة اللي حكينا عنها رح تكون friable. Press it into sieves with a mesh number 14, and these granules are wet, are put it in an oven with a temperature less than 56 Celsius, and dry it to make a percentage of moisture less, maximum to 2%, 2 milligram, 2%, sorry. So after drying these granules, we will add the rest of dry starch, that is integrant, the most important part. Then we will use lubricant and flow promoter and anti-adhesive. Really, talc and magnesium stearate is the lubricant and flow promoters, but because talc is less hydrophobic, magnesium stearate is the most hydrophobic agent, like oil. It is oily in nature but is powder, so we'll add talc 1.5%. It will be for our mixture 0.45 and mix it with the granules, and we mix with dry starch. Prior to tableting, we add magnesium stearate less than 1 minute and mix it. Then we compress our tablets and we form 600 milligram, the weight of each tablet. Eventually we will get less than 50 tablets because really we are using small scale hands. The percentage of loss here very high. Okay, I finished for this experiment. Please, this experiment does not have any report or counseling or any assignments. Thank you.